Hey guys, so I accidentally ended the previous video of this example, so I'm just going to call it traces. And so this is actually where we actually set the integrals up. So we did a lot of the work in the first video where we actually are trying to find the volume of this region bounded by these three surfaces, and really four. And then we did traces, and so I went ahead and rewrote the equations up here, which is what I was meant to do, and then go back and continue on with the video. So here it is, new video, but same problem. So the first thing we're going to do is we're going to set the integral up in terms of x, y, and z. So you will see that when we do this for the 6 times that we're really going to do the same kind of thing. It's the same process. So the first thing that I'm going to do here is I'm going to write down that dx is first. So I'm giving you two equations here, right? So I'm giving you that x is equal to the positive and negative square root of 1 minus y. So, and you look at these equations right here, this is what's going to help us set these outer region, this inner region up. So x can be, the furthest x can be is from right here and right here. When those are the curves of the square root of 1 minus y, and then the negative square root of 1 minus y. And so that's our first thing. So once we're done with that what we need to do then is we need to look at this curve right here, this trace, because we want to find the region of now dy and dx. So whatever our second and third change is, we always look back at this trace. So if I want to do dy next, we want to find the equations of that. Well, the right-hand equation for this is going to be y equals 1. I have no idea why that's a negative. So y equals 1. And then our other equation for this is going to be y is equal to z. So remember that when we're trying to go from right to left, we always go, the right-hand curve is our upper bound, and then a lower-end curve is our lower bound. So this is the equations for y equals for this region right here. And we'll use those again. And then likewise, when I'm going to z, right, well, these are going to be our variables. So remember, our very outer bound is always going to be the, in this case, our lower bound and our upper bound because we're in the z direction. So the lowest value that z can be is 0. And the highest z can be is actually going to be 1 because, again, y equals 1, therefore z equals 1. So this is going to be the integral that you're going to write if you want to do it with respect to dx, dy, dz. So let's actually do the exact same thing here, where we're going to now just change the dz and dy, which doesn't change things all too much. Well, the first thing that I want you guys to notice is that the first one is still locked, right? So we still have our square root of 1 minus y and our negative square root of 1 minus y as our bounds for dx. So then what we're going to do now is we're going to find the equations for dz. So we want what z is equal to. So since z is the top one, we're going to go the top curve minus the bottom curve. So our top curve is z equals y, so the top bound will be y. And then the bottom curve is going to be z equals 0. So we're going to make that 0. And then just like before, we're going to now look at if we want to do with respect to y, we want to look at the left hand curve and then our right hand curve. And we're doing that because y is in the traditional x-axis, right? So our furthest to the left is going to be 0, and our furthest to the right here is going to be 1, right? And so that's how we look at our curves for this. So in this case, y is the left and the right, and typically it's up and down. So that's what you would do for dx, dy, dz, and then dx, dy, and then, sorry, dx, dz, dy. So I'm going to pause it for a second. I'm going to erase this, and then we're going to go back and do the next two. All right. All right, guys. So I erased that. I'm going to go ahead and talk about, where is this? Let's go in terms of dy. So let's start with dy first, and then we can do dx, dz, and then we'll do dz, dx. So first thing we're going to do is we're going to look at curves of y. So we have the curve of y equals 1 minus x squared and the curve y equals z. So we want to make sure that the furthest highest value of y is actually right here, right? This is the furthest on the y-axis that we have. Well, that's actually the curve of y equals 1 minus x squared. So when I do my triple integral again for y, the upper bound for this is going to be 1 minus x squared for our dy. And our lower bound for this is actually going to be this plane y equals z. So these are the two equations that we have to do to determine what the equation, the surfaces is for y. Then we're going to look at this, right? So now we're going to look at this trace to figure out what we're going to do next. So we're going to go in terms of x first. So we want the surface of x for this problem. And actually, I need to do a quick little thing here and change this to minus z, right? I forgot to switch that over there, so my apologies. I knew I was going to get to it. All right, so what we're going to do now is we're going to look at, since this is x, we're going to say, well, this is the right-hand curve, right? So we're going to go from right to left, since we're in terms of x here. So we're going to go, a right-hand curve is going to be the positive 1 minus z, and the left-hand curve is going to be negative 1 minus z. So if we look in terms of x, our right-hand curve will be the square root of 1 minus z, and then our left-hand curve will be the negative 1 minus z. And then what we're going to do, so for the dz is going to be our lower and our upper bound, right? So z, the lowest bound z is in that region, is going to be 0, and the highest bound that z is going to be 1. So again, surface, this is going to be the function itself, and this is going to be our bounds. So if I do dy dx, oh sorry, just did that one, right? dy dz dx, just like earlier, we're going to say that the y is not going to change. All right, so now what we're going to do is we're going to look at z, right? So the z equations, well, the top equation, because now we're looking at top minus bottom, the top equation is going to be 1 minus x. So that's going to be z equals 1 minus x. And then the bottom region is actually going to be z equals 0. And so that's what we're going to do for the equations for that. And then for our x term, we're actually looking at the left bound for this, which is going to be a negative 1. And then on the right-hand side, it's going to be 1. And actually, let me, first of all, I always forget to do this, write down my changes with things. So with 2 examples down, I'm hoping that you guys are understanding. So when we do the last example, which I want you guys to try, you're gonna look at this trace right here. And it's very similar to what we just did in this right here, because they're the exact same pictures. So this is the idea that I want you guys to get out of this problem, right? Is again, that these are our functions, these are our curve surfaces. This is going to be looking at our traces. So we always look at our traces when we're trying to find the outer 2 regions. And we look at the curves, and then we look at our bounds. So what I'd like for you guys to do is actually see if you can do dz dx dy, and then dz dy dx. So pause the video and see what you guys can do with that one. No, we'll be right back. All right, guys, so I went ahead and plopped up the solutions to our last little piece. And so we're looking at dz dx dy. So the first thing that I want us to notice when we're doing these problems is the fact that when we're looking at z, we're looking at z is equal to y. This is our upper region, right, which is going to be this plane right here. And then the lower region is actually where z is equal to 0, right? It's actually this plane right here. So that may be a little tricky for you, but the lowest z is actually z equals 0, right? Because it's the lowest thing. We have to be bounded by this plane, where z is equal to 0. And the other thing is, it's actually given to you in the original problem, right? So I did not put those down here. So the bounds are going to be 0 to y for this. So the lowest is equals 0, and the highest is equals y. So once you do that, then you finally go over to this last little trace, this right here, where when we're looking in terms of x, let me bring this down a little for us, guys. So when we look at x, we're looking at our right curve versus our left curve. So just like in the previous example, we're going to look at the right-hand curve as the square root of 1 minus y, and then our lower curve will be negative square root of 1 minus y, and then the y value will be from 0 to 1, and so that's where our bounds are 0 to 1. When we come over here to the dy dx, we look at the equations, and now this is our y equations, where our top curve is going to be y equals 1 minus x squared, and then the bottom equation is going to be y equals 0, and then our bounds are going to be for x, the left-hand side is negative 1, and the right-hand side is positive 1. And so that's where you get the bounds for these integrals. So there you go. A very long problem into 2 videos. My apologies, should be 1. So hopefully that makes sense. And yeah, that was a good one. So I will talk to you guys in the next video. Take care.